Hi! Some time ago I built this little thing and actually it did a great job. Now I wanted to check if it's still working, so it's a nice opportunity to tell you something about it. I will present you with some background of this project so that you have an idea on why the heck have I need a pipe inspection robot and why I decided to make certain things the way I did. I'll tell you what went exactly as it was meant to be and what turned out to be a really bad idea. Finally, I'll show you how it works and what have I found in one old sewage pipe that once was a big headache for me. So let's get started. Okay, so how it happened that I decided to build pipe inspection robot? Long story short, my parents have a 50-year-old house and one day their main sewage pipe got clogged. They call a service that made it through using such high pressure device, and here the story would end, but unfortunately it didn't. A few weeks later they experienced the same failure. Once again, service arrived, cleaned the pipe and even inspected it with a camera like this, showing that everything is fine. Well, at least in places where they could see the pipe clearly. The problem was, this pipeline been modified some time ago. Originally, it was connected straight to a sewage collector. But over time, new sewage collector been built in this neighborhood, so to switch to new one, original pipe was cut outside the building and fitted with 120 degrees elbow, followed by the rest of new piping. As the service only had a camera that you need to manually push down the pipe, there was some blind area where the camera was just scraping the wall of the pipe before it finally changed direction. So when the pipe clogged once again, just a few weeks later, that was the natural place to be suspicious about, especially that it's not just an ordinary straight piece of pipe. You see, in 1970s, when the house was built, it was okay to put rainwater into sewage mines. And that was exactly the place where old rain pipe been falling into the sewage system. It's been blinded off on its other end long time ago, but for more than 20 years, rainwater carrying all sorts of stuff that wind and birds could made up the roof, been flowing through this point. So we had a good theory about where the problem can be and why it happened, but we couldn't even prove it. It's really difficult to fight an enemy you can see, so it was quite obvious that we need to find a way to figure out what are we dealing with and how effective are any countermeasures we take. We were in need of something self-propelled. A quick research in Google shown that, of course, such inspection systems exist on the market, packed with all kinds of high-tech solutions and readily available, for a price that I could easily replace this pipe and all the other pipes in the entire building. So at least there was a clear answer to the question DIY or buy. Fortunately, I already had some experience in building remote-controlled robots with camera, so I was excited that I can finally utilize previously gathered knowledge to solve a real problem. Unfortunately, it wasn't so sweet that I could just take one of my previous designs straight out of the shelf. This project had a lot of constraints that I never had to deal with before. First of all, it had to fit 120mm diameter pipe and be able to turn in this 120 degrees elbow. Additionally, this time the construction had to be waterproof, at least to some extent. Another thing was that previously I always used Wi-Fi for communication. As you can imagine, there is absolutely no option to communicate over Wi-Fi with a robot inside a thick-walled cast iron pipe lying more than 1 meter below ground. So this time I had to use a wire for communication. If I were to use a wire, I also had to make sure that my robot will be equipped with a drive capable not only to move the robot itself, but to drag up to 15 meters of such wire behind it. So I had to use much stronger motors than I used to. Bigger motors means increased power demand, especially that I also had to use some built-in light source and some logic that will handle camera streaming, communication and all the other stuff. Previously I've been using power bank, but this time I had to figure out something more sophisticated. Finally, one more thing that I rarely had to deal with in my previous projects. It was supposed to be ready fast. As fast as possible, because it was obvious that the pipe will keep clogging until properly fixed. Quite a lot of requirements for a project with short deadline, but basing on my previous experiences, I considered it doable, so I started gathering necessary hardware. Unfortunately, I couldn't find motors fitted with angle gear that would be strong enough for what I assumed, so I decided to use this model and make bevel gears myself. So I jumped into Fusion 360 and designed a bottom body as single element, so that it would be watertight straight after being 3D printed. It was supposed to accommodate both motors, which I intended to slide downwards into their slots. This way I had the center of gravity low, so my robot should be less vulnerable to flipping sideways. Motors are also less moisture sensitive than electronic components which I wanted to install above them, so they shouldn't fail immediately, even if some water would find its way inside and gutter on the bottom. The other gear was meant to sit on stainless steel shaft, rotating inside a brass bushing, sealed with O-ring and grease to be packed into this seat, and closed with second part after being mounted in its place. To save space, I decided to stick power LED with thermoglue to the front motor directly, so that it will be a heatsink for LED, and seal the port with plexiglass. Upper port was meant for Raspberry Pi camera, which I took from earlier projects, as well as Raspberry Pi Zero that was supposed to become a brain of my device. To make my life easier, I soldered motor driver directly to Raspberry Pi header and grabbed everything with 3D printed holder. Still, I had to deal with wired communication, but considering total wire length of approximately 20 meters, choice seemed quite obvious: Ethernet. Unfortunately, Raspberry Pi Zero doesn't have such interface out of the box, so I had to add such adapter connected to Raspberry over SPI. I still had some space behind camera, so I mounted my adapter right there. Okay, but if you're familiar with Raspberry Pi family, at this point you may ask, why not just use the B model in such case? It already have Ethernet on board? Well, this question brings us to the first and probably biggest misconceptions of this project. This model of Raspberry is slightly broader than robot body, but looks it fits above the tracks, so theoretically it should be possible to design the top compartment in such manner that it could accommodate it, right? Well, not quite. You see, originally this construction was not meant to use tracks. I was so much concerned that I need to be able to turn in this 120 degrees elbow that the first concept was about using two central wheels instead. Sounds absurd after a time, but back then the idea seemed decent. Until the first test, which proven that even though everything works fine on the floor, the robot becomes completely uncontrollable inside the pipe. It just kept crawling on the wall and flipping to the side eventually. Initially I thought that it might be due to poor traction, so I printed these wheels with rubber tires, but it didn't help at all, so I had to figure out something else. And it had to fit already existing body, because I had no time to start from scratch again. Finally, after a few hours of scratching my head nervously, I came up with a solution. The body was printed of ABS, so I could easily stick additional things to it with acetone. So I added these supports, made shafts for additional wheels, and replaced original wheels with a new design that was supposed to drive such 3D printed rubber tracks. And that was a really good shot. All the problems with steering suddenly disappeared. It also improved traction and few other things, so I was really happy about this upgrade. Such arrangement would also allow accommodating Raspberry Pi Model B, but the body being already manufactured considering previous version where it wasn't possible. So I had to continue with Raspberry Pi Zero, but actually I didn't regret it much, as besides small size, it also had the advantage of reduced power consumption. Speaking of which, I didn't yet mention how I plan to deliver power to all the receivers. Well, as I already decided to use an Ethernet cable, it was quite natural to explore the possibilities of PoE technology, which stands for Power over Ethernet. Unfortunately, as usual for this project, I couldn't just buy a proper adapter because it simply wouldn't fit the space I still had. Not to mention that it was supposed to have two voltages, 5 volts for Raspberry and 12 volts for motors. So once again I had to make something custom. There is one PoE configuration that is relatively easy to handle in DIY conditions. Obviously it's much wider topic, but as it's not a video about Power over Ethernet technology, let me just keep it as short as possible. Ethernet cable consists of 4 twisted pairs, but lower Ethernet standards use only 2 of them, so as long as you don't need highest possible data transfer rates, you can simply use those unused pairs as ordinary power cables. My data transfer was already limited anyway, by using Ethernet adapter over SPI, so that's exactly what I did. I carefully stripped a piece of external insulation, cut off spare wires and soldered them to a standard barrel jack socket. Those are still a really tiny wires, so obviously I had to be careful on how much current I push through them. To be able to send sufficient amount of power while keeping the current within reasonable limits, I decided to use 48 volts supply. It's still relatively easy to handle, and comparing to 12 volts, it requires 4 times less current to send the same power, so it seemed to be a good compromise. Such voltage is considered safe only in dry conditions, but I wasn't planning to enter the pipe together with my robot, so it was not an issue. Of course, I still had to convert this transport voltage into desired voltage levels inside the robot. For this purpose, I used such chips. They cost around $10 each, so it's quite a lot like for such low-level component, but I had to keep my design compact and reliable, so I considered it a fair price this time. So following instructions from datasheet, I assembled a circuit for both of them on a single custom-made PCB, sticked some small heatsinks, and even though I was really concerned on how it's gonna work, it did absolutely great. I never experienced any power-related problems, even with rapid maneuvering inside the pipe. As last step, I had to seal the joint between top and bottom compartment with acetone. This way I created a permanent bond between parts, which wasn't an ideal solution because from now on it was impossible to disassemble it without destroying the body. But it was simplifying the construction a lot, so I just accepted the fact that it will be difficult to repair it in case of any failure. At the moment, time was more important factor than maintainability. Cool, so after spending around $150 and more than a week of 3D printing, machining and assembling, I finally had my robot ready. But still it would be useless without proper software. As usual in this kind of projects, the most important factor was low latency. After a little bit of searching, I found this project on GitHub. It seemed pretty straightforward, so I managed to set it up quite fast. I just made a few essential modifications, and after a day of playing with code, I finally could control my robot from keyboard while observing the image on the screen. Due to hardware limitations, I could only afford 640 on 480 resolution at 10 frames per second, but I was far from complaining. It was good enough to figure out what am I looking at. Illumination was sufficient, latency was low enough so that I had no problems with steering. Of course, there was around 100 milliseconds delay, which was noticeable, but fortunately it wasn't intended to be a race car, so it was not a big issue for speeds I've been reaching. Sure, my code was really primitive as I had no time to implement any features beyond what was absolutely essential, so I don't want to waste time explaining it right now, but I'm planning to do a video about my other robot. Then I hope to have much more decent code base that I could share with you in details. Excellent! With my robot fully operational, I was finally ready to find out what the hell is going on inside this old pipe. And this is what I found. Exactly as we expected, there was a lot of sediments where rainwater pipe been entering main pipe. And it's been looking pretty solid right now. We tried to remove it with spring wire like this, but after checking the results of such cleaning attempt, it was clear that the progress is actually limited to fresh stuff. Same as it was every time service been cleaning it with their high pressure gear. Soft sediments blocking the top part were blown away, but already solidified bottom remained in place, ready to start the entire cycle over and over again. So thanks to the robot, now I knew that I won't be able to remove the root cause of clogging without using some sort of power tools. But how to use such tool 6 meters down the pipe? Well, necessity is the mother of invention. I already had two manually operated spring wires, one bigger, one smaller. What if I put one inside the other? This way I should be able to use a drill to spin some sort of tool head fixed on the other end. Tool head like this, for example. Yep, that looks promising. I just added such roller guides to make it sliding easier, and we were ready to test this concept. I just used the robot to make sure my tool is positioned precisely where it should be, and we turned the power on for around a minute. The following inspection showed that it's working, but it will take a lot more than that to remove all this rock-hard stuff that gathered there for the last half-century. After another 10 minutes of grinding, and grinding of the chains eventually, the pipe was finally free of obstacles. To be honest, it was a bit disturbing feeling to enter this black hole ahead, but I was curious how it looks further, so I just pressed forward, and the deeper I gone, the better it seemed to be. Finally I managed to move around 12 meters inside, and I was convinced that this time there will be no more surprises in the future. And so it was. It's almost 2 years now since these events, and there were absolutely no further problems. We almost forgotten that this pipe exists, which is how it's supposed to be. But in case of anything, tools are ready, robots still working. I doubt this operation would be successful without it. I hope you enjoyed the video. If you have any questions, or anything else you like to share, comment section is yours. Thanks for watching and see you on other videos.